Hey guys, so this is lesson 44, solving right triangles. And in this video, we're going to talk about, kind of looking at this example here, how to solve for different parts of the triangle, either the sides or the angles. So one little thing that it says here is sines, cosines, and tangents are ratios, and they're always the same for any given angle. Okay, and then it says since these ratios depend only on the size of the angle, and not on the size of the triangle, we can use them to find missing parts of right triangles. Again, we're going to use those trig functions, the sine, cosine, and tangent. So when we look at this one, just recall that we need to remember, and I usually write this at the top of all of these problems when I see that I'm using trig functions to solve for the right triangle parts, SOHCAHTOA. Okay, and remember that sine stands for opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so we have to figure out which one of these trig functions we need to solve for certain missing parts of the right triangle. Now, if you see that you have a right triangle and one other angle, then solving for this angle is not that difficult, right? We know that all three of those angles in the triangle add up to 180 degrees. So maybe the first thing I would do is solve for angle B. Okay, so I might write an equation like this: 24, angle 24, or I should say 24 degrees plus 90 plus B, angle B, is equal to 180. You could also say that 24 plus B is equal to 90, okay? So let's just say I do that. Then I add these up, and I get 114 plus B is equal to 180. And then if I were to subtract 114 from each side of the equal sign here, okay, I would get B by itself, and that would be 66 degrees. 180 minus 114 should give you 66 degrees. So now we have both of these angles, okay? And now we can solve for these sides. Right now, notice we have two unknowns here for the sides, so we can't use Pythagorean theorem like we would normally do. We need two out of the three sides to use Pythagorean theorem, so we're going to have to use some trig here. And what you can do is you can either use the angle that you found, or you can use the one that's given. I'm just going to go ahead and use the one that's given, like they do in the book. And what I would do is maybe, let's say I want to solve for h at this point. That's probably the harder one to solve for, but I'll go ahead and do that one. So if I want to solve for h, okay, then I want to use this angle, and I need to use one of the sides that was given already, okay? And then I got to figure out if I'm relating this side that's next to, remember adjacent means next to, relating that side that's next to it with the hypotenuse, which function is that? Adjacent and hypotenuse. Go back up here and go, oh, well, that one's got adjacent and hypotenuse, so I'm probably going to use cosine, right? So you can then write cosine, and then normally you have an angle. On the last video, you didn't see the angle, but this time, well, you might have actually, but we're going to actually put the angle that we're referencing into our cosine. So cosine of 24 equals, okay, and then what does it equal? It's the adjacent side, oops, down here, adjacent side, so 9.5 over the hypotenuse, which is h. And so now this equation only has one unknown, and we can actually solve it. Now, what makes this one the harder one is that the h is on the bottom. But that's not really a big deal. What I would do then to get h by itself is I would actually, and you're allowed to do this, multiply both sides by h. So if I multiply both sides by h, these h's will cancel, right? And I'll get h times cosine 24 equals 9.5. And then from there, I can actually solve for h by dividing both sides by cosine 24. So I'm going to divide both sides by cosine of 24. And then I'm just going to put that in the calculator. So in the last lesson, you actually learned that you could put it in just as you see it, which is really nice. I'm going to clear this out. So h is equal to 9.5, so I'm going to type that in, 9.5 divided by cosine of 24. And again, make sure you're in degrees. And so I end up getting 10.4, basically, when it rounds up. So h is equal to 10.4. Okay, and that actually makes sense because look at this. This leg is 9.5. The hypotenuse should be longer than the leg, right? And then the only other thing I have to solve for now on this triangle is y. And so now I go, okay, well, let's just go ahead and use that angle 24 again. So if I want to solve for y and I want to use one of the sides that was given, I would try to relate these two things. I'd go, okay, well, this is the side opposite, and again, this is the adjacent side. Which one of these up here has an O and an A? This one. So I'm going to use tangent. So I say, okay, tangent of 24 equals. So again, I'm using this angle, so I have to put tangent of that angle. And that equals opposite, which is y, over adjacent, which is 9.5. This one's nicer because notice the y is on top. So it's nicer to solve for y. I can just multiply both sides by 9.5 to get y by itself. I'm going to do that, 9.5. And then all I have to do here is say, okay, let's just plug this in the calculator, 9.5 tangent of 24 degrees. So here we go again, clear it out. And then I'm going to do 9.5 tan of 24. And I get 4.23. So 4.23 equals y, or y equals 4.23. So now I've solved for all three missing parts of the triangle. All right, so here's another one. So example 2 in the book. So here it's kind of a similar situation, except this time they gave us the hypotenuse. So this one actually is nicer when you set up the trig ratios. But again, you're given one of the angles and you're given a right angle here. So you can actually find angle B doing the same thing we did last time. So we're going to do 35 plus 90 plus angle B equals 180. And then when you add those two together, you get 125, add the like terms together, plus B, angle B equals 180. Then subtract 125 from both sides. And then you're going to get B equals 55 degrees. So now we have solved for angle B. Now let's solve for M and X. Okay, let's just do X first. So X, okay, so looking at this angle here, 35, if I look at that angle, then I can think, okay, I need the opposite side, and I have the hypotenuse. Once again, I'll just slide this back down again. We're dealing with the SO part of the SOHCAHTOA, right? Opposite and hypotenuse, which is sine. So we're going to use sine. So I'll say sine of 35, this time my angle is 35, equals opposite, which is x, over hypotenuse, which is 14. And again, this is one of those nice ones. To solve for x, just multiply both sides by 14. And so I end up getting 14 sine of 35. I just plug it in here. So 14 sine of 35. And I get 8.03. So 8.03 equals x, or x equals 8.03, okay? Now let's solve for the last part of the triangle, so M. Again, I'm going to go ahead and use 35 degrees. So from here, I'm wanting the side that's adjacent to that angle, and I know the hypotenuse. Okay, and so adjacent and hypotenuse. Let's go back up here and go, oh, yeah, adjacent and hypotenuse, that's cosine. Okay, so we're going to use cosine. So let's do cosine of 35, that's our angle, and then we're going to say, okay, that's adjacent, which is m, over hypotenuse. So m over 14. And then to solve for m, multiply both sides by 14. So hopefully you're getting the hang of this at this point, and we're going to still do one more after this. So this one is 14 cosine 35. Oops, go back a little bit. And you get 11.47. So 11.47. All right, so we solved for all three parts of that triangle. And then now the final one. So the final triangle, final example in here is this one. This time, notice we don't have any angles, so that's a little different. We were given two sides this time, okay? So again, when you have two sides of a right triangle, the first thing you should think of is, oh, I can solve for the third side using Pythagorean theorem. You probably guessed it. And again, be really careful. It's always leg squared plus leg squared equals hypotenuse squared, okay? Make sure you put them in the right place. So when we're solving for x, again, think a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. So leg squared, we're going to do 6 squared plus leg squared, that's x squared, equals hypotenuse squared. Okay, and now we can solve this. 6 squared is 36 plus x squared equals 49. And then if I subtract 36 from both sides, I get x squared equals 49 minus 36 is 13. And then to get x by itself, I need to undo this squared, which is using a square root. So I'm going to take the square root of both sides. And we're just dealing with a positive square root of 13 because this is talking about length. So we're not going to consider the negative case. So now we know that x is root 13. And now, on the last video, we talked about how to solve for angles using the trig ratios. Remember, if you're trying to solve for an angle in a triangle and you just have the sides, you can actually use inverse trig functions to solve for angles. So what we want to do then is, just pick. We can either pick the one we have. I think what I'm going to do is just pick the one, the sides that they gave us instead of using this root 13, but you could use it if you want. I'm just going to use the 6 and the 7, and I'm going to try to solve for angle A. So for angle A, I have the side that's adjacent, which is 6, and I have the hypotenuse. So remember, adjacent and hypotenuse, that's cosine, okay? And if you need to, again, just write SOHCAHTOA, okay? And then you'll be able to see, oh yeah, adjacent and hypotenuse, that's the cosine. So you can say, okay, cosine of A, this time we don't have the angle, right? Equals the adjacent over the hypotenuse. And again, from the last video, just recall, to get A by itself, you've got it in the cosine function. So you basically are undoing that. So to undo a cosine, you take the inverse cosine. So you say A equals inverse cosine of what it is, 6 over 7. And if you do that, you're actually going to get an angle. So just recall, when you're doing this on the calculator, inverse, you have to press second and then the cosine, and that'll give you that little -1, which is meaning the inverse cosine. And then we do 6 divided by 7. And we end up getting 31 degrees. So angle A is approximately 31 degrees, okay? And then we could actually use another trig function to find b if we wanted to. We can also, if we know this is 31, we can just think, okay, well at this point, you know 2 out of the 3 angles in the triangle, so you can just solve for that last one, writing this equation. So you can say 31 plus angle B plus 90 equals 180. And then those two added together make 111 plus B equals 180. And then if you subtract 111 from both sides, then you'll get your angle B. I feel like I did something in here real quick. Let me just check. Huh, yeah, 121. I knew there was something funky about that. So 121, subtract 121 from both sides, okay? And you get 59. And that should be it. So 59 degrees. So hopefully this was helpful, and now you can solve all of the triangles using either the trig function, Pythagorean theorem, or inverse trig functions.